Hi guys, in this video I'll be discussing about AWS Redshift in detail. We'll start with an overview, try to understand the advantages, some of the features, and also look at the architecture to understand how Redshift works in general. Right? We'll also look at a couple of ways you can actually create a Redshift cluster, either by provisioning the number of nodes or by making use of serverless features that is available in Redshift AWS console, right? And we'll also go ahead and create a new database. We'll create a table along with some constraints, distribution keys, sort keys, and we will also query some of the table data in this tutorial. So let's get started. So first thing first, Redshift is actually built on top of PostgreSQL. Even though it is an RDS system, it is still used for OLAP along with some added features in the Redshift, right? So that makes it compatible to work with any data warehouse systems, wherein you can run any type of analytical queries, aggregations, or any transformation on higher number of records, right? And since it's distributed in nature, having features of columnar storage, massively processing, Redshift is assumed to be at least 10 times higher performance when it compares to any other RDS systems. In order to understand the columnar storage concept, I have an example here. I have a sales fact along with couple of dimensions. So in a typical row-based storage format, the entire record is saved in each blocks, and also it depends on the block size. Just for this example sake, let's assume that one record is equal to one block size. Let's say it's like 32 KB or 64 or whatever it is, right? So typically if you have five records, it will consume five blocks of space. In a columnar format, each column value is saved in each of the blocks, right? So you will, if you have like four different columns, it will occupy four blocks. Again, it's an assumption that size block and the set of data what you have makes up to one single block, right? So typically when you do some aggregation, let's say you want to find out what's the sales total sales amount. So in a row-based storage format, you would actually scan five blocks to arrive at the sum of sales amount. Whereas in columnar storage format, it will just scan only one single block and it will give you the results of the aggregation, right? So that's the huge difference. So row storage does lot of scanning of the each of the data blocks. So the IO operation is higher in case of storage and row storage, and it's actually minimal in columnar storage format. So typically, row storage format is primarily used in OLTP systems, wherein you may want to completely read one single record. Let's say if you're booking for a flight, you want to know the name and location, starting point, ending point, and everything. Each and every detail you want to show it on the screen, right? So in those typical OLTP use cases, row storage format performs better because at a time you will be looking at only one customer or one particular transaction on the screen, so that makes more sense with the row based storage. But in case of columnar, it is more suitable for analytical processings, so such as if you have a data warehouse or any decision making system. So in those areas, you will be, columnar storage, makes sense. And since it has a columnar storage, the data retrieval and aggregation or any group by activities would be much faster when compared to row storage. Because when you perform any analytical reporting, you're not trying to display entire record set, right? All you wanted to know is the sum of sales amount, average of sales amount per region ID. So in those use cases, columnar storage performs much better, and that's the primary use case for columnar. And Redshift is one of such columnar storage. And to understand massively processing, we'll discuss through the architecture. Right, and moving on, AWS provides two different ways to spin up a new Redshift environment, either through provisioning a new cluster or make use of serverless instance. The advantages of cluster is you get to choose the type of instance and number of nodes and other parameters when you create your own cluster. In the serverless fashion, everything is customized. You don't have to worry on the type of node and the number of nodes in the serverless fashion. So this is one of the recently launched offering from AWS side. And moving on, AWS Redshift works in leader and compute node fashion. We'll look at this in and also discuss when we talk through the architecture, right? And also supports Spectrum. So Redshift Spectrum is meant to read data directly from S3 buckets, right? So if you have like data files directly in the S3, you can actually create some external tables and access through your Redshift resources. If you have your cluster spinned up, your Redshift Spectrum will be making use of the same cluster resources. And also AWS provides flexible backup and restore, and also supports cross-region backup. In case of any disasters, it will be really highly available in case of any issues or disaster, right? So moving on, here is the architecture of Redshift system. And if you notice, the first thing to notice here is the leader node, and the second is the compute node, and third thing is the slices in between each compute node. And connection to any Redshift systems can happen either via JDBC or ODBCs. So whenever a user is trying to query, pass the queries for query execution, so leader node is responsible to take all such query requests and pass it to compute nodes that are healthy and that are available for computational purposes, right? And since it's a distributed system, you can have any number of compute nodes in your Redshift cluster. Um, and also each compute node will have two or more slices. So slices are nothing but the actual working unit. It will have its own separate memory and also the disk storage. So which means all the computation happens at the slice level. And since the table data is stored in partition based on the slices, right? It's a distributed, right? End of the day, the processing also happens at different slices. So thus increasing the performance and increase, this is one of the feature of massively parallel processing. The leader node is also responsible for making sure that each of the compute nodes in a healthy state, and in case it is not healthy, or if a compute node is really occupied, it will automatically send the request to other compute nodes, right? And then the data is aggregated and the result set is transferred back to the users. So this is the overall functional architecture of Redshift. Now let's go ahead and look at the AWS console to understand how do we create a new cluster. So I'm on my AWS console. This is the console home, and if you look at it, this is the Redshift service. So here is the serverless option. We will look at this next. And if you scroll down further, you will get an option to create the cluster. And if you want to look at the pricing options, you can actually check it. So there are two ways you can rent or lease your Redshift cluster. One is through on-demand pricing and also the reserved instance pricing. So the pricing for reserved will be much lower when compared to on-demand. So let's go ahead and create a new cluster. Create cluster. And the first thing is to name your cluster. This is the cluster identifier. I'll just keep it as learning with Rohan. And this is the important thing. You will have to choose free trial. So remember, this free trial is applicable only for the first 12 months of sign up. So make sure you use a new account. And when you scroll down further, so here there are different types of instances that are available since we have chosen the free trial. The by default we are gonna get DC2 large, one node, right? The free trial we get only one node of type DC2. DC2 is nothing but dense compute, right? And this is the two is number two is the generation, and this is the size of the cluster, right? So with this, you get with the compute node, you get a two core. This is the generation two, and there will be only one single node of two virtual core CPUs, right? So if you were to provision on demand, it's going to be this much pricing. You can take a look at it. I'll not waste time there. And it also comes with a sample data set. Ticket is the sample database that comes with this cluster setup. And here's the admin user. You can change it or continue using this particular thing. I'm going to go ahead and create a strong password here. And once this is done, you just go ahead and create a cluster. Okay, and also you make sure you don't pass any ampersand. This will not be accepted here. So I'll use something different password. We'll go ahead and create a new cluster, and I'll save it for now. Okay, so the cluster will be in a creating state. It will take some time, and let me pause it for a minute. And also if you scroll down further, you will see this is the new cluster that is getting created, and it is in modifying, which is creating status. And the free trial instance comes with one single node with the storage of 160 GB of disk. So one thing to notice here is if you are trying to configure external client applications or make use in a different computer, you may have to set or create a appropriate IAM role which will gain access to this particular service for the external users, right? And also if you're trying to access the Redshift database from outside, you'll also have to set up your security group to allow all the incoming traffic on 5439. That's the port that is used by Redshift. So you'll have to open up that port as well. All right, so the cluster is successfully created. And if you scroll down further, you'll be able to see the cluster identifiers, right? So with this link, you will be able to create, you can copy the JDBC URL. And if you go back to, so let's say Notepad, you should be able to get the JDBC string. So if you were to connect, configure and connect via client tool, you can make use of this JDBC connection. So likewise, you can also copy ODBC URL. I'll just quickly show you. So this is how the ODBC connection string looks like. So this is how you'll be able to copy the URL, and whenever you work with external client tools, you should also be downloading the AWS SDK. So there'll be a jar file that comes with respective versions of the Redshift. Make sure you download this particular driver and pass it to the client for the connections. So this AWS SDK will ensure that smooth connectivity and the data transfers between the client tool to the Redshift. So for now, I'll be directly querying the data from the console itself. So there is an option you can actually query the data. So before that, you can see the status as available. And if you look at this cluster and the new window, right? So this will give complete overview of the entire cluster, right? So this is the cluster identifier. The status is available. This is of node type. You can copy the endpoint directly from here, right? Number of nodes and date it was created. And when you scroll down further, you can set up all the alarms, CloudWatch alarms to set up, like if your CPU goes beyond certain limit. So those type of alarms you can create it. And when we start running queries, it'll start showing up the CPU utilization, the disk space utilization, right? All the number of database connections. So these statistics are shown on this particular dashboard. And please note there is no memory usage anywhere, right? It's just about CPU, disk, number of connections, and the overall health status. And while you are running query, you can also get to this query monitoring tool to see all the queries that are running in the system to understand what type of operation is going on, right? It shows the database performance and workload concurrency and etc. Right? So let's go ahead and create a new query. The Redshift query editor. So this is the Redshift query editor, and on the left hand side, you will see the connection, right? And as we were discussing, there will be a default database that is created. So this is the sample data, right? And the name of the database was ticket, right? So this will have a set of tables that you can make use of it, or else we can create our own new one. So every installation of Redshift will comes with a default dev database and a public schema in it. So dev is the database, public is the schema in it. You can create multiple schemas in a database, and each schema will have number of tables, views, functions, and stored procedures. So these are the objects within the hierarchy. It will also have a set of tables. If you expand the tables, right, you will have by default you will have these many tables. So I just clicked on sales, and you will get to see the type of the columns, the fields, the data type, and whether it's a null or what's type of compression. So by default it has taken AZ64 compression, but when you create a new set of tables, you can change them, right? And also Redshift doesn't enforce the primary keys and foreign keys. Instead, you can actually set up the distribution keys and sort keys, right? In this particular scenario, list ID is used as distribution keys, and date ID is used as a sort key. Because since it's a sales fact, you may have data varying based on particular calendar dates, right? So that's the reason date ID is most likely classified as sort keys. So what happens is you have like 5 years or 10 years worth of data, and you are looking at only last quarter data. You don't have to scan all the older date ranges. So thereby your number of scans to that through the data blocks will be reduced. It will scan only the date IDs that are in the last quarter date range, right? So likewise, the distribution keys is based on the list ID. So list ID, what happens is the table, the record set in this particular table will be distributed based on the number of compute nodes that is lying underneath. So in our case, it's just one node, so it doesn't make any sense. But in the real-time scenarios, you will have multiple compute node, multiple slices of data. So you can have your data distributed at across multiple nodes, right? So let's go ahead and create one new table along with all the constraints. Let me actually pull up the existing sales table DDL. So here is the table DDL. It is exactly like other RDS instance. Create table name, and it'll have number of columns and the data type and the constraints. So constraint here is not null, and if you notice the data type is integer. There is a provision for small int, big int, and decimal, right? The timestamps and the string, right? So in this case, if you notice, this event ID is also having a custom encoding, which is the 16, right? Likewise, you can have different encoding like delta 32. There's no mandatory that you have to specify any encoding format based on the type of data and the type of data set. Redshift will automatically have this data encoded in certain format. But if you have any data regulations or data requirement to encode the data in certain format, you can very well do that using this particular feature. And next thing is Redshift also supports primary keys and foreign keys, but this will not be enforced at the database level. So which means you just have to mention it here, but the actual applications or an ETL flow should take care of making sure that none of the entries for sales ID be duplicate. So the application is responsible for, the external application is responsible for taking care of all the constraints, right? And also if you look at it, the foreign key list ID and the foreign table is the listing. So you will have a listing table, and if you notice on the left hand side, there's a separate table, and this list ID in this table is referring to the list ID of listing table. So that's what it means. But please note, the keys are not enforced in Redshift. And the way you set up the dist key is based on this syntax, dist key, and you will supply the column that you want to distribute. Right? You can have a single or else multiple. So likewise, you can also set the sort key for a one single column, or you can set the sort key using a multiple column list. So when you choose like multiple columns, it is called as compound sort key. If you're just specifying one, it is just simple sort key. If it is multiple, then it's a compound. And there is another sort key which is called interleaved. So whenever you have a combination of data such as city and a state, which is repeated values, so those type of data points you can even use interleaved sort keys, right? So this is in general how DML contains various thing. And on the action, we should be having something called as delete the cluster. So this will ask us to confirm to delete, right? And then delete the cluster. So this will take care of terminating your cluster. And if you see, it is in the modifying state, and it will take a couple of minutes and it will shut down.